let's get started. Gerardo and Jennifer leave the same restaurant at the same time, leaving in opposite directions. If Gerardo travels 5 miles per hour and Jennifer travels 12 miles per hour, how long until they are 85 miles apart? Okay, so let's see. I'm gonna have to reread this one. They leave at the same time. They're going in opposite directions. If Gerardo is 5 miles per hour and Jennifer is 12 miles per hour, so Gerardo is going much slower. I don't know if that's important, but we do have a distance on this one. Well, with that, then I guess I am expecting this to be a distance relationship, because our final answer here, or total, is in some form of distance right there. It's 85 miles. Now we know, again, from a couple slides ago, that distance is the same as taking the rate and multiplying it by the time. And in fact, well, they did say how long is it until they are 85 miles apart. So I'm going to say, I'll use T in this case, just because it is time. T is the time, how long it takes, I'll put. We got the two distances. We'll go with Gerardo first. Okay, so I don't want to write, that's kind of a long name for me, Gerardo, plus I'm not sure I could spell it right. Gerardo, I'll do Gerardo in red. Well, Gerardo, his distance is the rate times the time. Up here it says Gerardo, he's going 5 miles per hour, okay? Now, because we do want the distance, his distance is just, I'm gonna take it, his speed, and multiply it by the time. I don't know the time, but, so I'm gonna just define it as T on that. Okay, so that's Gerardo, that's his distance. Then we also have Jennifer, right? So I'm gonna take Jennifer down here. We'll do Jennifer's in purple. So Jennifer, it says she is going 12 miles per hour, so she can go 12 miles per hour, but we don't know how long she's gonna be doing that for. So I'm gonna multiply the 12 by the T, okay? Now, these two distances should give us the total distance. Which we know is 85 miles. Okay, now, here's the other thing, is their distances are getting farther apart as they travel. So the two distances here, I'm gonna have to add them together, and then that would give me my total. Okay, now you have to do some thought, because I think there's some of these where you end up subtracting them. Could be wrong about that. But again, put some thought into this, and make sure you're doing it. I think I did that right, by the way. I think I'm using the correct variable as distance, right? Or time in this case. So yeah, I'm gonna put that in the video. The distances that they travel are not the same, so that doesn't really help us in an equation. The speeds, they told us the speeds were not the same, so that doesn't help us either. It's the time that will be the same. It's the factor or the variable that it has to be consistent. Otherwise, we end up with two variables, which we don't want. So this one is so great because it's so close to being finished. All I gotta do is combine my terms, the T terms. 5 T's plus 12 T's is 17 T's, and this still equals 85. But then, even then, it's just one final step to solve. All I gotta do is take both of these and divide them by the coefficient, which is 17. So I got 17 divided by 17, phantom 1. T then, T is how long it will take. Well, that would be 85 divided by 17 is 5. Now, how long, this is not how long in distance, it's how long in time. That's why we use T, and time in this case was in hours. It'll take them 5 hours until they are 85 miles apart. Okay, now you can check this as well. Okay, so if this takes 5 hours, Gerardo would have taken 5 hours at 5 miles per hour. 5 times 5 that would have been 25 miles for Gerardo. Okay, now it's not 85, but together it's 85. So if Jennifer takes, she's traveling 12 miles per hour for 5 hours, she would have traveled 60 miles, and then 25 plus 60, it does equal 85. So you can even check these ones when you're doing them to make sure that they're going to give you some truthfulness from the original conditions that were given.